Hello everyone, welcome to TrueTech Academy. I am the Tirumalesu, new faculty dealing with transportation engineering. In the transportation engineering, major part and most important part of the most important part in the JEs and all the exams, that is geometric design of highways. In the geometric design of highways, what is the importance of geometric design of highways? Let's discuss. Firstly, we have to construct a highway that is based on the visible features and layout of the dimensions, and that dimensions is fixed by this geometric design only. And in that geometric design of highways, it deals with the cross section of elements and cross section of elements and the side distance consideration and horizontal alignment details and vertical alignment details. In the cross section of elements, it deals with the, for example, this is the highway. In that, how what is the carriageway width and what is the shoulder width and how much we have to design, how much we have to provide, and what is the cross slope and what is the camber. And in that, what are the factors affecting this geometric design of highway, geometric design. And in that we are dealing with that margins, and in that we have to dealing with that for example, this is the two-way highway and this is the median. In that we are discussing about that how much the distances we as per the IRC, how much distances should be provided, minimum distances should be provided as per IRC. We are dealing with this. And side distances consideration, this is the most important part and a very easy part for understanding to everyone. And another one is the horizontal alignment details. Horizontal alignment is nothing but the horizontal curve. In that we are discussing about the super elevation and design of curves. And another one is that vertical alignment details. In that we are dealing with the design of vertical alignment, that is vertical curves that are the summit curve and the valley curves. We are dealing with that IRC considerations also. And in that let's discuss about that what are the factors affecting. Now let me discuss about the what are the main factors affecting this geometric design of highways. That is, first one is the topography and design speed. These are the main most important factors that are consideration in the design, and the other characteristics that are the road user characteristics and the vehicle characteristics and traffic capacity and environmental considerations. And now first one is the topography. Topography is nothing but ground surface and how much the undulations are provided are present in that ground surface. Let's take a for example, we have to construct a highway in the we have to construct a highway in the now we have to construct a highway in the terrain slope. For example, that is this much of slope. So we have to consider the how much this slope is having. And let's say this is the plain terrain. In that we will construct the highway very easily. And rolling terrain is nothing but this, like this. And for according to the as per the IRC is nothing but the Indian Road Congress. Indian Road Congress. This is the authority which is the deciding the parameters of the road. And in that, as per the IRC, plain terrain having a cross slope of 0 to 1%, If the ground having a cross slope of 0 to 1%, we will classify it as a plain terrain, and if the cross slope is having a 10 to 25%, then we get, deals with that, we will call it as a rolling terrain. If the cross slope is 25 to 60%, we will classify it as a mountainous terrain. If the cross slope is greater than 60%, greater than or equals to 60%, we will classify it as a steep terrain. Steep terrain is nothing but like this, and we know about this cross slopes also. Now let's, after some time, we will discuss how it affects the geometric design. And another one is the design speed, which is the most important factor that affects all geometric design, like side distances also, horizontal alignment also, vertical alignment also. In that, as per the, in the design speed also, most important design speed also depends on the, we will fix that factor depending on importance of road and terrain or topography. Let for example, if we construct a village road, for that we there is no need of the design, no need of the speed of 100 kmph, so we will design for 40 kmph. And another one, we construct a national highway or state highway. For that we have to go with more speed, so we will go with that 100 or 80 kmph. So importance of a road also important factor for that fixing the design speed. And the terrain and topography, if the, let's say we are having a, wait, now we are having a steep terrain of in the, shall we ride with a bike with 100 kmph? It is not possible and it is not safe also. So terrain or topography is also important factor in the geometric design, and that is fixing the design speed. And the importance of road also important factor in the fixing the design speed. So as per the IRC, this is the design speeds of design speed in kmph. Let's say in kmph, these are all in kmph. So these are the design speeds that are as per the, that are taken into consideration as per the IRC. This is NH means national highways and state highways, major district roads, MDR means, ODR means other district roads, VR means village roads. These are the plain terrain and rolling terrain and hilly terrain and steep terrain. Let's observe in this. For national highway and state highways, if we have a steep terrain, we have to, the minimum speed and minimum design speed is the 40 to 30 kmph. If it is a plain terrain, then the minimum design speed is the 100 to 80 kmph. And this is the important factor that we consider in the design of highways. And other factors, that is other factors, road user characteristics. Road user characteristics is nothing but the height of driver and visibility of the driver, and those are the road user characteristics. And vehicular characteristics, nothing but the brake efficiency and the friction between the tire and the road surface. These are coming under the vehicle characteristics. And another one is the road user characteristics and traffic capacity. This is the most important thing that we are considering in the geometric design. We design a traffic based on future capacity. So let's say consider the we are constructing a road for the in this year, but we have to consider the how much will be the traffic after 10 to 15 years. So that is the traffic capacity we have to take in. And another one is the environmental consideration. Environmental consideration means, like in our India, some part of the India is the western, north part of the India is having most of the season is having less temperature. In south part of the India is having more temperature. From that also we can we can take these environmental considerations, and these are the other factors that affects in the geometric design of highways. And now in the geometric design of highway consisting of, first one is the cross section elements. Let's say cross section element nothing but that this is the road surface and this is the ground surface. Let's say we are constructing a road surface on this. This is the road surface and this is the shoulder wheel, and these are, for example, this is road surface, and in that, let's say for some vehicle is going on, how much this from this what is the this lane width, and what is this how much this shoulder width, and how much the carriageway width, and how much the formation width, and how much the right of way width, and what are the pavement characteristics, like how the pavement surface is happening, how the pavement surface is looking like, and these are the cross section elements that are coming under these are the elements that are coming in cross sections. And now in that, pavement characteristics and width of pavement or carriageway, and we have another diagram is there, I will explain in that. And camber is nothing but the cross slope, and median and curves and road margins and right of way. These are the elements that are coming under these cross section elements. And in that first one is the pavement characteristics. In pavement characteristics, friction. First one is the friction. Now let's wait for some time. Okay, friction. Friction is nothing but the we know the what is the friction. Friction is nothing but the force between the two members. That is, here we are considering the shear force between the tire and the road surface. So this is the main important factor that we considering in the cross section elements. In that, we have longitudinal friction coefficient and lateral friction coefficient. Let's say this is the road surface, this is the road surface. Longitudinal friction coefficient is nothing but the when the vehicle is going along the road surface, the friction between the road surface and the vehicle tire. Vehicle tire is the longitudinal friction. Vehicle tire is the longitudinal friction. That is the longitudinal friction. The coefficient is 0.35 to 0.4 as per IRC. This is coming. And the main important factor that are effects in this friction are the first one is vehicle type, and second one is the road condition. If the road condition is smooth road condition, then the friction coefficient is very less. And the vehicle type is nothing but the if the tire, sorry, vehicle type, not vehicle type, tire condition. Tire condition. If the tire condition is good, then the friction developed between the road surface and the vehicle tire is good. So these are the factors that are affecting the friction. And the lateral friction coefficient, this is this longitudinal friction coefficient is we are using in the design of side distances and in the design of horizontal alignment also. And vertical friction coefficient is mostly used in the design of curves, horizontal curves and vertical curves also. Horizontal curves and vertical curves also. This is coming under lateral friction coefficient. This importance of this lateral friction is the when the vehicle is traveling through curve, there is some force is acting on this side, that is a centrifugal force. To counteract that centrifugal force, there is a friction is developed between the tire and the road surface in transverse direction of the road. not in longitudinal direction. This is the transfer direction of the road. So along this transfer direction of the road, there is a friction coefficient developed. There is a friction is developed to counteract that centrifugal force. So this is the lateral friction coming in the design of the these curves, horizontal alignment or horizontal curve. So as per the IRC, this is the value that is taken into consideration, that is the 0.15, and the lateral friction coefficient, the lateral friction coefficient is 0.15 and longitudinal friction coefficient is 0.35 to 0.4. As per the, these are the values as per the IRC. These are the values as per the IRC. These are the most important in the competitive exams. Like they will ask in the exams also. So these are the important. And next one is the skid or slip. Skid is nothing but the, for example, this is the road surface. Let's say we are skidding. Skidding means let's say this is the tire of the vehicle. Skidding means when the friction is no friction is there, the vehicle, the tire of the vehicle tire is going towards along the longitudinal direction without revolving. So this is nothing but the skid. And slip. Slip is nothing but the revolving the vehicle tire at the same place. In simple, I am saying in simple terms, so that this is the difference between skid and slip, and these are the considered. These are considered in the cross section design of highway also. And another one is the now pavement unevenness. This is also one of the pavement characteristics. Pavement unevenness is nothing but the undulations that are present. Along the road surface is nothing but the pavement unevenness. We are measuring this pavement unevenness. That is, we have to measure how much the undulations are present along the road surface. That is, for example, average for let's take a road surface of 1 kilometer. In 1 kilometer, how much undulations, average undulations, height of the average undulations, for example, 1 centimeter per kilometer. This term is called as unevenness index. The unevenness index is the term which is used to measure the pavement unevenness or the undulations that are present along the road surface. So, what is the so this is the pavement unevenness and unevenness index. Now, what is how to measure this unevenness index? We are saying that unevenness index is the undulations, average undulation height along the road surface. So, how to measure this unevenness index? That is the bump integrator. Bump integrator. This is the diagram of the bump integrator. This is used to measure the undulations that are present on the road surface. So this is the unevenness index that are let's say for example 1 centimeter per kilometer or 4 centimeter per kilometer. And now this is used in IRC, Indian Roads Congress, and as per the IRC, good pavement is having 150 centimeters. Sorry, 150 mm per kilometer, not centimeters. Centimeters means too much. So, and another thing, this is for this is used in our country only. For in the world, as compared to the equipment used or the term used for the pavement unevenness is the IRI. IRI is nothing but the International Roughness Index. IRI is most important. International Roughness Index. For this, this is also International Roughness Index is also measures the pavement unevenness. There is a relationship between the bump integrator, that is pavement unevenness index, into IRI also, that is equals to bump integrator equals to 623.7 into IRI power of 1.2. This is the formula between the bump integrator and this is the relationship between the bump integrator and the IRI, International Roughness Index. These are the pavement characteristics, and the cross section element, in the cross section element, this is the pavement characteristics, and another pavement characteristics is also there. Let's say this is the width of pavement or carriageway. I am saying that now we are discussing, now these are the cross section elements. Now we are discussing with the pavement road cross section, road cross sections. Let's say this is the carriageway. Carriageway is nothing but the we are saying that road surface, but the technical term is the carriageway. Okay, we are saying road surface, but technical term is the carriageway. That carriageway is nothing but the distance between this where the distance between not distance. This is the surface where the vehicle is travels. That is the carriageway width. This carriageway width is depends on the type of road. And the mainly length of vehicle also. Based on the length of vehicle, we are fixing this width of carriageway. So width of pavement or carriageway. This is the width of pavement or carriageway. And another one is these are the shoulders. The main functions of the shoulders are constructed in both sides of the pavement, both sides of the carriageway. Let's see, this is the main image. This is the carriageway where the vehicle is traveling, and this is the shoulder width. And this is the shoulder width. Okay, these are the shoulder widths, and the main function of the shoulder width is to support the load, distribute the load coming from the carriageway. And another one, it will create a more space for the stopping the vehicle while in emergency. That is also useful for. And main thing is the more space is available, and this is the formation width. And next we will discuss about the formation width. Formation width is nothing but the width of carriageway. Here I am writing that formation width equals to width of carriageway plus shoulder width. This is the formation width. And another thing is the after this formation width, we are having a cross slope for the draining of water while in the rainy season. And these are the cross drainages that are constructed to drain the water. And another one is the boundaries. These are the boundaries for the future expansion also. And here we can observe that building line is also there. Building line distance means these are useful for the future widening also. And this is the control line, that is the final width. and from the distance between this final to, like from the both sides, from this control line to this control line is called as the right of way. Here this is the right of way. Right of way is the distance between the two control lines on the road surface, and this is the typical cross section of the road surface. And now we are coming with now you can understand the how the payment, how the typical road surface is being, and how we construct a road. Now, as per the IRC, the width of carriageway is the 3 point for single lane way, for single lane road. This is the 3.75 meters, and for double lane 2 lanes road 7 meters, and 2 lane with raised curbs is 7.5, and multi lane payments is 3.5. These are the main. This is the width of carriageway as per the IRC, and you have to mug up with these values. These are important in the RRB JE and SSC JE exams also. And for example, single lane, you can understand the single lane means here you can understand this is the single lane. For example, only road surface is there, here shoulder and here shoulder, and again the remaining drainage these are coming. So if the lane is only one and the road vehicles are coming this and this side along the both directions also in single lane, so this is the, so we have to there is a requirement to more the requirement to give the more width for the vehicle movement. So we are giving the 3.75 meters, and for single double lane, for two lane means this is the two lane road, single way traffic, and this is also two lane road, single way traffic, and without raised curbs. Without raised curbs means there is a curbs are there. So if the curbs like this, for example, this is the road surface and this is the raised curb. If raised curb is there, then the width of carriageway is 7.5 meters. If there is no raised curb is there, width of carriageway is the 7 meters. And the multi-lane payments, if for example we have to construct a highway of 4-lane road, okay, 4-lane road, then what is the width of this one-way lane? So sorry, width of this one lane, that is 3.5 meters, and this is 3.5 meters, 3.5 meters, 3.5 meters. We have to multiply how many lanes are there. You can now you can understand how these how we construct a road surface, and what is the width of the road surface, and we have to important thing is the width of the carriageway is based on the width of the carriageway is depends on the length of vehicle, not length of vehicle, width of vehicle. See, width of vehicle. If the width of vehicle normally as per IRC based on the some consideration, width of vehicle is 2.5 to 2.7 meters is there. So not 2.5, not 2.7. This is not a fixed value. Based on this, they are fixing the width of carriageway, taking into some factors also. Now here is the some important note is there. The width of pavement is increased on horizontal curves. For example, like this is the road surface. If there is a horizontal curve is there here, and now there is some extra width is we have to provide. That is nothing but the setback distance, not setback distance. Wait. That is the offset. Offset is nothing but the extra width that is provided at the horizontal curves to safe movement of the vehicles, and the horizontal we have to off tracking or offset, and there is also psychological winding is also there. That is also a deep discussion. we are not covering that, and that is called as the extra widening. That is called as a extra widening. Some formula is also there, WL square by 24, like that. There is a no need of that. And now, and this is the, you understand the width of pavement or carriageway. Now we are dealing with another cross section element, that is camber. That is camber. Camber is nothing but the slope of the road surface along the transverse of the road surface. Let's see. For example, this is the road surface along longitudinal direction. Let's say we have to construct a cross section of the road surface here. How it will look like this? How will it look like? This is the cross section of the road surface. Here you can see, but here we have to provide some slope. We have to provide some slope. That is nothing but the camber. That is nothing but the camber. Camber or cross slope that is provided along the transverse line of the road surface, transverse direction of the road surface. So in that camber, there are three types of cambers are there. First one is the parabolic camber, and second one is straight line camber, and third one is the combination of straight line and parabolic camber. And first we have to discuss about the what is the importance of this camber, or why we have to provide this camber, right? Why we have to provide this camber. First important thing is the if we construct a road surface like this, and for example this is the road surface as a straight line, so we have to construct a so this is straight line. When there is some in the rainy season, when the rain is drop off, so some water is stored on the road surface, it will affect the pavement design, and it will affect the pavement materials, and it to pavement materials, and it will permeable to the deeper layers of the pavement. So pavement will be weaker. So to drain off this rainwater very easily, we have to construct a camber. And another thing, to provide a safe movement of vehicles along the road surface, we have to provide this parabolic camber, not parabolic camber, the camber. These are the importance of the camber we have to provide along the road surface. And in that, first one is the straight line camber. Okay, first one is parabolic camber, the next one is the straight line camber. Straight line camber is nothing but this is straight line camber. We are not using that, but we have to discuss this straight line camber. This is the cross slope 1 in n. 1 in n nothing but the n horizontal units of n horizontal units, 1 vertical unit. For example, let's say width of the pavement is this is the halfway width, so we have to take in 2.5 meter. For 2.5 meter, for example 1 centimeter is the camber height. 1 centimeter is the camber height. This is the cross slope. This is the cross slope, that is nothing but the 1 in 2.5 centimeters or 2.5 meters. Like that we have to say. I am not considering about the units, and I am not dealing with proper done. But I am saying this is the concept behind the straight line camber. Like that also we are dealing with parabolic camber. In the parabolic camber, the camber is that the road surface of the top road surface is parabolic in shape, and this is the straight line in shape. And both sometimes we are using the combination of the straight line and parabolic camber also. Now most important thing is the top or highest point of this camber is called as crown. Okay, this is the most important thing, and it may be come in RRB JE also, like that. And this is the crown. Crown is nothing but the highest point of the camber, and there is a, for parabolic camber, this highest point distance y equals to 2x square by nw, where n is the slope and w is the width of pavement and x is the horizontal distance, like we are saying 1 in n x y, right? Here we, like, wait, here x and y is there, so 1 in n, like that. Here x in y, so you will substitute these values. So how, what is the, this distance from the horizontal surface is the y, horizontal surface is the y equals to 2x square by nw, y equals to 2x square by nw. And like that also, for a straight line camber, it is the useful in RRB JE. These are the some simple calculations will be given in RRB JE. And this is the straight line camber, that is w by 2n. The crown distance is the w by 2n. And as per IRC, now these are the recommended values of the camber as per IRC. And here also we can see that topography effect in this cross slope, that is heavy rainfall area and low rainfall area. In that the cross slope is 1 in 50, that is 2%, 1 in 60, that is a 1.7%. You can ask us some doubt, is 1 in 50 means where is the units? Where is the unit means 1 meter for 50 meters horizontal, 1 meters vertical for 50 meters horizontal, like that. Or otherwise 1 centimeter vertical for 50 centimeters horizontal, like that. These are the values you can understand, and these are the, as per IRC, these are the as per IRC, these are the standard values that are given. Now let's go into deeper. Now medians and curves and shoulders. I have shown in the picture how the medians are there and how the shoulders are there, and these are the main values. These are the, as per IRC, these are the main these are the standard values that are to be taken in the design. For the minimum width required for the highway is 5 meters, and if the land is restricted, then it will be decreased to 3 meters, and along the bridges the height width of the median is 1.2 to 1.5 meters. And mostly these values are dependent on the land acquired further and the type of road and importance of road also. And another one is shoulders. Shoulders are constructed on the both sides of the carriageway. The functions of the shoulders is to drain off the water also and to support the main carriageway, and it is useful for the traffic, useful for the stop of the to stay with the vehicles on the shoulders. Now minimum width of the shoulder should be 2.5 meters on one direction, and the camber should be 0.5 to 0.5% steeper than the camber of road. This is most important topic, most important point, because for example, let's see, this is the camber, this is the carriageway width, and along the carriageway width some shoulder is there. So if the shoulder, for example, the camber is 2% of cross slope, so if the shoulder is more than this, not steeper, like lesser steeper than this camber, then the water is stored at this junction, so that we have to provide more steeper than the camber, that is the camber shoulder should be 0.5% steeper than the camber of the road, and the minimum camber of shoulder should be 3%. Sorry. Now right of way is nothing but the, there is a formation width is there, Let's see. Sorry. This is the roadway. Along the roadway, this is the carriageway, and from this, some shoulders are there. Shoulder width. Here, formation width is there. The formation width is nothing but the shoulder carriageway width. This is carriageway. I am saying carriageway is nothing but the road surface, and this is shoulders, and this is also shoulders. So the formation with nothing but the distance between the shoulder to shoulder, or otherwise carriageway width plus 2 into shoulder width. That is the formation width. And the road margins. Road margins is called as the formation width. Is called as some normal land width of required is for national highways and state highways is 45 meters. This is as per IRC. And maximum land width required for the national highway and state highway is the 60 meters. And this is right of way is nothing but the, after these shoulders we have to construct a some drainages. We have to construct some drainages to drain of the water. After that, some land is required for the future equipment, future constructions. So total distance from these outer line to these outer line, from these outer line to these outer line is called as right of way. Is called as right of way. I am saying, I am teaching in simple words. So this is the right of way. These are the cross section elements. Okay, these are the cross section elements that are considering that are I am teaching that what are the, as per IRC, what are the requirements, what are the values are there, and let's discuss the side distances in next class. Thank you so much.